Alright, these are 4H notes. We're going to be solving systems of quadratic inequalities and equations. Okay, so the first thing we want to do, we're going to look at two different methods for solving these systems. We're going to be graphing two different inequalities and seeing where they intersect. We're going to look at graphing method first. So when you do the graphing method, you want to solve for y for each one of these because you want to put them in standard form so we can graph these. Now, I didn't leave you a tremendous amount of space on here to do the work for graphing, so you may want to do the extra work on a separate sheet of paper. But please take good notes so that when you go back and look at this, you know what you did. So let's solve for y. And here, let's solve for y again. So we're going to put them in a form that we can recognize so we can graph each one of these. All right, so we need to graph each one of the inequalities. I'm sorry, the equations. So just to practice, this is in standard form. So you have an option. You can find the vertex by using the opposite of b over 2a and then find the corresponding y. Or we can use completing the square to put this in vertex form. Since that's one of the topics that we're studying right now, let's go ahead and practice putting this in vertex form on this first one. Okay, so I'm going to put this equation in vertex form. So I'm going to move the 1, leave myself some space to find my c. All right, let's find c. So it's half of b squared. And I'm going to add that to both sides. So let's clean this up. So we're going to have y plus 1. Well, negative 2 divided by 2 is 1. Negative 1. Negative 1 squared is positive 1. All right, we need to factor this. So it's going to be x minus 1 squared. And then if I move over the 2, now I have it in vertex form. So that means my vertex here is 1, negative 2. So let's graph that. So 1, negative 2. My a is 1, so I'm just going to do the standard parent pattern. Right 1, up 1, reflect. Right 2, up 4. And reflect. All right, we want to graph as many points as we can. So go right 3, up 9. And reflect. And 416 won't fit. All right, be really careful when you draw this. Try to hit your points. Since my graphs aren't accurate, it's going to be hard to see where the two intersect. All right, now I want to graph that second equation. I'm going to change colors. So let's graph the second equation. All right, here this is in vertex form. So my h is 0 and my k is negative 1. This time my a is 2. So we're going to have a vertical stretch. So 0, negative 1. Well, it's already touching my purple graph, so there's one answer. You're looking for two answers in these. These can have up to two answers. So you want to keep graph as many points as you can to see if they intersect again. All right, so right 1 up 2, reflect. Right 2 up 8. And left 2 up 8. All right, so they're intersecting there again. So once you find them intersecting twice, that's the most they're going to intersect. All right, so my two answers are where they intersect. And when you're solving systems, your answers are always ordered pairs. So we need the coordinates of those ordered pairs. So one answer is 0, negative 1, and the other answer is negative 2, 7. So when you find a system, what you found are these points, x and y, will make both equations true. But you've got to always remember to write your answers as ordered pairs. All right, so that's with solving it graphically. Let's solve it analytically now. So that just means you're solving it algebraically. So we want to start off again by solving both equations for y, which we did before. And this is the easiest way to do this. And now since both of them are equal to y, we can substitute, set them equal to each other. We're substituting one of the equations in for y, but just set them equal to each other. Okay, and then we're just going to solve for x. All right, and here again it's a quadratic, so we're looking for two x's. So we're going to subtract x squared, so I get x squared, add 2x, add 1, which is 0, and this is going to be equal to 0. I want to factor, so these have a common x, so I'm going to factor out an x. You can never divide by an x, because if you divide by an x, you're throwing away one of your solutions. We're looking for two separate x's here. Use the zero product property to find my two values for x. So x equals 0 and x equals -2. Now, once you find your values for x, you've got to find your corresponding values for y. So you're going to pick one of the equations above. It doesn't matter which one you use. And you're going to plug in your x's and find the corresponding y's. I'm going to use this equation because it'll look a little bit easier to me. All right, a little fewer terms to plug in. So I'm going to substitute in 0. And that's going to give me -1. So my first answer is 0, -1, which should be the same answer we got before. All right, now I do the same thing with -2. So plug in -2. All right, -2 squared is 4. 4 times 2 is 8. Minus 1 is 7. So my second answer is -7. Here again, remember, anytime you solve a system, your answers are always ordered pairs. All right, let's look at another example. All right, these are already solved for y. Here again, we're going to solve these by graphing, and then we're going to turn around and solve them analytically. You need to know both methods. You can't just focus on one. All right, they're both in vertex form, so they're going to be easy to graph. So 0, -4, and a is 1. And this is -2, 0, and a is 1/5. All right, so 0, -4, and my a is 1. So my standard pattern, right 1, up 1, and then reflect, 2, up 4, reflect, and then 3, 9. Here again, you want to graph as many points as you can, especially on that first graph. Okay. All right, connect your dots. Be really careful. Like I said, you want to try to make an accurate graph as possible. Try that again. Okay. All right, that second one. Let's draft that one. All right, so -2, 0. Well, there's one answer. Remember, I'm looking for 2. All right, here my a is 1/5, a little bit harder. So 0 gets me 0. Let's do something that's divisible by 5, like 5. When I square it, I get 25. And when I multiply by 1/5, I get 5. Let's start there and see if that is enough. If not, we'll make some more points. All right, right 5, up 5. All right, look, it's intersecting, but then we need to finish our parabola. So let's reflect that point. Okay, and we're going to connect those points. So my two answers are here and here, where the two graphs intersect each other. Now remember, I have to give my answers as ordered pairs. So that means my answers are what? -2, 0. And this is 3, 5. Okay, so like I said, you must write your answers as ordered pairs. Must, must, must. All right, let's solve this one analytically now. All right, they're both solved for y. So now I just need to set them equal to each other. Okay. Well, I don't like that 1/5 in there, so I'm going to multiply everything by 5 and get rid of that fraction. All right, I need to solve for x. That means I need to FOIL this out. I'm going to x squared plus 4x plus 4. All right, now I need to get it in standard form. I'm just solving for x. So subtract x squared, subtract 4x, and subtract 4. All right, I look at this and I see I've got a common factor of 4. So that means I'm going to divide everything up here by 4. So I'm going to get what? X squared minus x minus 6 equals to 0. Now I need to factor. So it multiplies to give me -6, but has a difference of -1. So what? -3 and 2. Since my lead coefficient is 1, I can go straight to my factors. All right, use the zero product property to find my zeros. So x is equal to 3 and x is equal to -2. All right, remember you're not done until you find your y values. Answers have to be ordered pairs. So pick an equation. I'm going to use this one. So if x is equal to 3, we want to find out what y is. So that's going to be 9 minus 4, which is 5. So one answer is 3, 5. And if you leave them like this, separate, it's wrong. Like I said, your answer needs to be an ordered pair. All right, let's find the other answer, -2. X is -2. Let's find our corresponding y. So that's going to be 4 minus 4, which is 0. So my second answer is -2, 0. You must write your answers as ordered pairs. Okay, 2 more topics in these notes. So let's look at graphing a system of inequalities. So there's going to be shading involved here. We're going to shade what makes both inequalities true. We're shading where these two are going to overlap. So let's start off by graphing that first, y greater than or equal to 2x minus 4, 2x squared minus 4. It's going to be a solid line. My vertex is 0, -4, and a is 2. So 0, -4. And a is 2. So I'm going to write 1 up 2, reflect, write 2 up 8, and reflect. All right, remember you want to take it all the way off the graph. So 318 is not going to fit. So let's connect those. It's a solid. Okay. All right, now I'm going to figure out where I would shade. I'm not going to shade yet, though. So this is greater than, the y is on the left-hand side, so I would be shading above. So I'm just going to put some arrows to that would indicate where I'm going to shade, because I want my final answers where the two overlap. So if you do too much shading, it just gets really messy. All right, let's look at our second one. All right, this is less than, so it's going to be dashed, and the vertex is 0, 3, and a is -1. So 0, 3. All right, this thing gets flipped. So I'm going to go write 1 down, reflect, write 2 down 4, reflect, write 3 down 9. All right, remember you want to take it all the way off the graph. So this is going to be dashed. Okay. All right, now, where would I shade? It's less than, the y's on the left, it's less than, so I had to be shading below. Well, our answer is where they two intersect. So where do we have both colored arrows? And this kind of egg-shaped thing in the middle. So where you shade, that's your final answer. So any point in that region is going to make both of these inequalities true. So what are some examples? What are points that are in both of this region? Well, there's 0, 0. All right, we could do 1, 1. We could do 0, -4, because this is solid, but you can't do 0, 3. That one's not going to work because this is an open. It's dashed. So anything on the dashed line is not going to work. So any points, and we can be infinite number of points, any points within that shaded region are going to make both inequalities true. All right, your final topic for today is going to be how to solve a quadratic inequality algebraically. All right, so it's all about learning this process, and I'm stepping you through it here. The first thing you want to do is you have to find what we call critical values. So you're going to solve this as if it wasn't an equation. So we're going to make this equal to. We're going to come back and look at that inequality in a moment. But to find the critical values, we need to make it equal to. All right, so step 2, we're going to write it in standard form. So we're going to get ready to solve this thing. So subtract x, or add x, and subtract 12. All right, let's factor it. So what multiplies to give you -12, but has a difference of 1. So 4 and -3. Since my lead coefficient is 1, I can go straight to my factors. All right, zero product property, so I need finding my zero, so set each factor equal to 0. and solve for x. So x is equal to -4 and x is equal to +3. So those are my critical values. My final answer to this is going to be an inequality. It's going to be an AND inequality or an OR inequality. All right. So what I'm doing now is the process to help me figure out if it's an AND or an OR. What you next want to do is plot those two critical values that we just found, -3 and 4. And because this was greater than or equal to, these are closed dots. That word's closed, not dozed. Closed dots. So let's pick a place for 0. All right, -4 and +3. So we want closed dots on -4 and 3. So what we've done here, we've divided this number line into 3 regions. And what we're going to do to figure out what our inequality is, whether it's an AND or an OR, remember ORs point out and ANDs point toward each other, we're going to test 3 regions. So we're going to pick a number to the left of -4. How about -5? All right, we're going to pick a number in between -4 and 3. Let's pick an easy one. Let's pick 0. And let's pick a number to the right of 3. Let's use 4. I'm testing those 3 regions. And what you're going to do is you're going to graph where it's true. Good thing to write down. Graph where it's true. Okay, write that down. I write it, you write it. Okay, so let's go back to the original inequality. This is where that greater than or equal to sign's coming in. And we're going to test to see if we get it when we plug in -5, whether we make this true or false. So -5 squared greater than or equal to 12 minus -5. So 25 greater than or equal to 17. Well, that's a true statement. That means I'm going to graph to the left of -4. All right, let's text 0. Let's put 0 in. So 0 squared greater than or equal to 12 minus 0. 0 greater than or equal to 12. Well, no. It's false. I'm not graphing in between -4 and 3. All right, let's try 4. 4 squared greater than or equal to 12 minus 4. 16 greater than or equal to 8. That's true, so we're going to graph. All right, your final answer has to be an inequality. And this is because they're pointing out this is an OR. So your final answer is x less than or equal to -4, or, and you do have to have the word, x greater than or equal to 3. Your final answer is going to be a compound inequality. Now what happens here is any numbers in those regions will make that inequality true, that original inequality. That's what you're solving for, trying to find what makes it true. All right, let's look at one more. Also here, let's go back for a second. Notice that this was a greater or equal to. Greater is an OR. So kind of think about what you think your answer is going to be before you begin. All right, don't rely totally on that, but say, okay, I think this answer is going to be an OR, and then check your numbers to make sure. All right, let's look at one more. All right, so the first thing I'm going to do is turn it into an equation and find my critical values. Put it in standard form. All right, you should notice that everything is divisible by -2. So let's do that. Let's divide both sides by -2. Just gives me smaller numbers to work with. So this is going to give me x squared minus 6x plus 8 equal to 0. All right, I'm doing all this to find my critical value. So I want to factor what multiplies to give you 8, but adds to give you -6. So -4, -2. So since my lead coefficient is 1, I can go straight to my factors. Use the zero product property. So x is equal to 4, x is equal to 2. All right, so now we're going to test our region. Remember, our final answer is going to be an inequality, either an AND or an OR. And you may have looked at this and said, oh, greater is going to be an OR. But let's, like I said, we think it might be an OR, but let's go through and check our values. All right, pick a spot for 0. That's 2, 3, 4. It's greater, so it's going to be open circles at 2 and 4. All right, I need 3 regions. Something to the left of 2, well, I'm going to be simple and easy on myself and use 0. Something between 2 and 4, well, that's 3. And something to the right of 4, I'm going to use 5. All right, go back to the original inequality to check these values. So negative 2 times 0 squared plus 12 times 0 greater than 16. Remember, I'm going to graph where it's true. Well, 0 greater than 16. That's not true. So I'm not graphing to the left of 2. All right, let's try 3. Plugging in 3. All right, that's 9. That's negative 18 plus 36 greater than 16. 18 greater than 16. That's true, so I'm graphing in between 2 and 4. All right, one more part of this. Let's check 5. Plugging in 5 for x. All right, what's that? 25 times negative 2 is negative 50 plus 60 greater than 16. Well, that's 10 greater than 16. That's false, so I'm not graphing there. So there's my answer between 2 and 4. Now, I've got to write this as an inequality. That's an and inequality. 2, so x is less than, I'm sorry, start that again. X is greater than 2 and less than 4. My answer is between 2 and 4. Well, that's an and. You said, well, I thought we said it was going to be an or. Why? Why did this thing flip over and turn an and? Well, look at that negative 2. Remember dividing by negative 2? What happens when you divide by a negative? It flips your inequality. So this turned into a less than. So it's an and. So that's why I warn you, don't just look at the inequality. Actually test the regions to make sure the inequality hasn't flipped over on you in the process of the problem. Okay, if you have any questions, please let's talk about them in class.